Can you see the screen, students?
No, sir.
Just a second. Yeah, okay. What about now?
Yes, sir.
Yeah. So as I told you, we'll be starting with the part of the syllabus. So that is the project evaluation and review technique. Okay, so that is your part. So you can see on the screen now. So this is PERT, PERT, project evaluation and review technique. So take down this particular sum. Okay, so I'll just dictate it for you, and as well as after this sum, you can take down the table as well, which is there next to this particular problem. Okay, so arrow diagram. Construct a arrow diagram for this problem. Construct a arrow diagram for this problem. State the expected. State the expected project completion time. State the expected project completion time. Second one, determine the probability. Determine the probability that the project will be completed. Determine the probability that the project will be completed in 55 days. Project will be completed in 55 days. Third one, suppose the company agrees. Suppose the company agrees to finish the project. Suppose the company agrees to finish the project in 50 days, 50 days, comma, failing to which, failing to which it would pay, failing to which it would pay a penalty of, it would pay a penalty of rupees 500 per day. Pay a penalty of rupees 500 per day, comma, then what is the probability, then what is the probability that, what is the probability that a penalty of, a penalty of not more than 2000 is paid. A penalty of not more than rupees 2000 is paid. What is the probability that a penalty of not more than rupees 2000 is paid? Full stop. Fourth one, obtain the, obtain the earliest and latest, obtain the earliest and latest start time and finish time. Obtain the earliest and latest start time and finish time for the activities. Earliest start time, sorry, earliest and latest start time and finish time for the activities. Full stop. Last one, fifth one, determine the variance of the project length. 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 Okay, take down this particular table which is there on the side. So name, predecessor, most optimistic. Okay, it is also called as MO and also denoted as A. Okay, then most likely ML, denoted as small m. Most pessimistic MP, denoted by B. Take down this fast, then let me know. Faster, students. In this sum, we need to cover too many of things. Done copying, students? Can I move ahead?
No, sir.
Fast. Okay, while taking also, I'll be needing a calculator for you. Okay, so you'll be having a calculator with you. Please make sure that you have it. So you need to calculate few of the things here. Calculator and also the Z distribution table, Z tables. So in the normal distribution table, if you remember, you had that particular Z tables. So have that also with you. So I'll be using that. If you are not having, not an issue. So I'll be explaining here. But when you are solving, so make sure you have it with you. Okay, so that you could check out like how we got that those particular values. So calculator and Z distribution tables.
Done, sir.
Okay. So now those who have not yet finished will be on the screen itself till I explain some things here. Okay, so till then you can copy this. So if you see the table here, when we compare this particular table with the CPM table, okay, there you had only the activity, the predecessor, and the time taken. Okay, here in this case you are having three times. Okay, three timings they have given. So they have not they have mentioned here. Okay, day 500 per day. So that means whatever the numbers you can see in this particular table, it is in terms of days. Okay, 4 days, 6 days, 8 days. So here we are having three durations which are given to you for each activity. So in the first activity, if you see A predecessor, so A is the first activity. So there is no predecessor. So there is nothing that will precede A activity A. So for activity A, we are having three different timings. So one is most optimistic. That means the lowest time taken, okay, or the fastest work done is taken as 4. So for activity A, there are three durations. So first is the most optimistic. That means the lowest time that activity could take. So that is 4 days. So second one is most likely. So this means is what is the like actual time duration what you may take. Okay, so that is most likely. Then most pessimistic. That means the maximum amount of time that you are or you will be taking. So that is the most pessimistic. So if you see for activity A, 4, 6, and 8. So 4, as I told you, the lowest time taken by any person for that particular activity. So that is 4 days. So most likely will always be between the most optimistic and the most pessimistic. So if you see it is 6 for activity A, that is 6 days. And most pessimistic, I told the maximum time taken or the maximum duration taken to complete that particular activity. Okay, that is 8. So 4, 6, and 8. So again, see if you see the question, the first thing is construct the arrow diagram. So again, the arrow diagram means whatever diagram you have done. Okay, earlier. Okay, what is that called as? So anybody can tell me what is that called as? The diagram what we drew earlier.
Network diagram.
Yeah. So the network diagram is also called as an arrow diagram. So again, here we need to draw a network diagram. So that is the first one. So first part or first bit is to draw the network diagram. So if you just go on and see the fourth one, again the earliest start time and the finish time, we did it right. EL, ES, okay. So EF and latest LF. So those things they have asked here again. So even in PERT also they can ask you the same thing. Okay, and here one more additional thing what we are doing is not one, two things basically. One is the variance. Okay, we are finding the variance and the probability of some of the things happening. Okay, so if you see here second and third, if you see second bit, they are asking you what is the probability of completing the project in 55 days. So here probability is the one that is additionally added to this particular problem, like when compared to CPM. And the third one, the third point in the question, it says if I am thinking of finishing the project in 50 days, okay, and there is a penalty of 500 rupees per day after 50 days, okay, and what is the probability of me giving the penalty not more than 2000. So this is again the probability they have asked here. Okay, so we'll go one by one. So but first, before going to the diagram, drawing the network diagram, so instead of three, so we need to make it as one duration, okay, or one time taken. So how to do that, I'll just explain. Okay, so instead of, they have given you three, right? Mo, ml, and mp. That is most optimistic, most likely, and most pessimistic. I can't use all the three, but using these three, I'll be arriving at one number. Okay, and that number, how to arrive, I'll just tell you. Okay, focus here. So now expected time te should be written here. Expected time, you can see here the formula. I can note down solution. Expected time te is equal to a plus 4m plus b divided by 6. Take this down. Expected time te is equal to a plus 4m plus b divided by 6. Okay, so wherever you have taken the problem, okay, so there are further activities that needs to be put here. Just a second. Yeah, so you can see here a to h. So what is the sum? I'll just go back and check. So till I it is there. Okay, so here also till I you can see. So TE it is written here. So in the table, TE sigma I and sigma I square, that is standard deviation and variance we are calculating. So these three additional, you can have the what you call columns. So if you don't have space over there, you can draw it somewhere else, not an issue. But the name should be written. That is the activities, and in front of that you can write this. Otherwise you'll get confused. So after expected time t is equal to a plus 4m plus b divided by 6. So this is that particular te. Okay, so a again you can see here. That's why I have written this as a. A is most optimistic, m is most likely, and pessimistic is sorry, b is most pessimistic. So most likely is the one which we are giving more weightage, so 4m, and the other two are just one number, that is a plus 4m plus b. So if you see here, how many are there? 4. This is 4. This is 5. And this is 6. So basically, we are taking the average kind of thing. Okay, that's why it is divided by 6. Okay, so this is 6 are there. 4m is 4, 1b is 5, and 1a is 6. So divided by 6. So this is the average time what we are calculating here, or the average duration that we are calculating for the activity. So by calculating this a plus 4m plus b divided by 6, for a I'll write here. For a is equal to, so no need for writing it, okay, because you have already written here. Or you can write te is equal to, in front of it you can write this particular equation. Then directly you can write what is a. So in this, a is 4. So 4 plus 4 into what is m? 4 into 6. 4 into 6 plus b. What is b? B is 8. So this is 8 divided by 6. When we calculate this, that's why I asked you to get the calculator. So other sigma and sigma I square also we need to calculate again. So for that also we need a calculator. So when you calculate this, I am getting as 6. So are you getting 6 here? TE first one. So here 6. You guys are getting 6. 4 plus 4 into 6 plus 8 divided by 6. So similarly, for all the other activities, for A, B, C, D, E, F, G, H, I, we need to calculate this TE. So, okay, so this is the time duration which I will be writing after drawing that network diagram. We write the activity and in bracket we write the duration, right? So we are writing this particular duration TE, what we are calculating now. Okay, so I'll be not explaining much about the network diagram and all. We have seen it in CTM. So I'll directly give you the whole thing. That is the uh, duration, the forward pass, the backward pass, and the critical path also. So everything is done. The next slide I'll just show you. So till then, copy this TE. Copy the T. We'll come back to sigma and sigma I square later. So and the formula for sigma I also is given here. Sigma I is equal to B minus A divided by 6. B minus A. So again, B is most pessimistic, A is most optimistic. Okay, B minus A divided by 6 will give me my sigma, that is the standard deviation. Okay, so till here you copy, TE you add, then write down the whole the values, or you can calculate those later. Okay, with this particular calculation. A is equal to, I have given here, next B, C, D. Similarly, using a calculator, you solve and find out TE. So after finding TE, we'll go to the next step, that is the network diagram. So network diagram, using this, I have already drawn the network diagram, okay, using this particular table here with TE as my uh, duration, okay, and these you should not use, okay, this should not be using. So using these particular three things, I have already arrived at TE, so I need to use TE. So the network diagram looks like this at the bottom. So A, you can see there is no predecessor to A, it starts at 1 and ends at 2. Again B, so B and C, if you see, A is the starting point. So B is on 2 to 3 and C is 2 to 4. So similarly, D and E. After B, I am having D and E. So where is B? B is from 1 to 3. Sorry, 2 to 3. So if you see here, so B, the D and E. So this is E here and this is D here. Okay. So just check again, D somewhere it is coming. Yeah, H is there. So DE I need to write after F. So check whether you can interchange this whenever we are having a burst event. Okay, whenever we are having burst event, check for any activity later on which there is a predecessor of. So H is having D here, D and F. So I need to check F. Where is F? So F is F is here. So after C is F. So where I need to get? So after C, F is there. So I need to make a what you call merge event at 6. So after that only I can draw H. So if you see here D and F, after D and F, I am having H. Okay, so that's how we need to draw this. I'll not go much deeper into this, but you need to focus that duration A6. Okay, 6. I am taking TE only. A6. Okay, next B, if you see, it is 8. So I am calculating here TE is 8. Right. So this is how you need to draw the network diagram, and the forward pass and the backward pass. This is used for finding out the earliest start, earliest finish, latest start, and latest finish. Okay, so check out my the CPM solved problems where how to do the forward pass and the backward pass if you are not knowing, or if you want to know more again. Okay, so using those, I am finding out the forward pass, backward pass, then the critical path. So if you see the different paths A, B, E, G, I, and when I calculate all the durations, add all the durations, it is coming to 47. Next is A, B, D, H, I. Okay, or if you want in numbers, A, B, E, G, I is 1, 2, 3, 5, 7, 8. Okay, 1, 2, 3, 5, 7, 8. And the second one, A, B, D, H, I, it is 1, 2, 3, 6, 7, 8. Second one, and the third one is ACFHI, that is 1 2 4 6 7 8. So this is the uh, in terms of the nodes in numbers, so it will be there. So in terms of activities, I have written here, and the duration with the maximum activity, that is 47, will be your maximum duration. So duration is 47. Okay, and check for the forward pass and backward pass where we are having the same numbers. So in this case here 32 40 32 40 40 47 40 47 14 32 14 32. Okay, 6 14 6 14. So these are the areas or the activities where the forward pass and the backward pass is the same, so which constitutes the critical path. So the critical path is 1 2 3 5 7 8 or ABEGI. Okay, so that is the critical path with duration 47. Okay, so this is we are basically solving the fourth and fifth. So if you see, okay, the fourth, okay, earliest start, earliest finish, determine variance, we will do it. Then the project duration. Okay, so they have asked you state the expected project completion time. The project completion time is 47 days. Here the duration is the 47 days. So we have already drawn the arrow diagram also. So by doing that, we have found out the project completion time, which is 47 days. Okay, and earliest start and earliest finish also we have completed. Now coming to the other part. Okay, so now coming to the other part. What is the other part now? We need to find out the variance. Okay, so why we need to find the variance is because so we are using the Z formula. Okay, the Z tables, if you remember, normal distribution. Z is equal to x bar minus mu divided by sigma. So to find the sigma, we need to find the variance. Okay, the sigma is a standard deviation. Standard deviation, variance. Okay, so I'll tell you what to do about it. So if you see here, okay, so if you see here, since the critical path is ABEGI, that is 47 days, the project completion time is 47 days. So this is the first one. I have not put the number here. So the first one, duration, I have put. Okay, next is variance we need to calculate. So for variance, what we need to do? Again, I'm coming here for variance. Okay, for variance, if you see, what is happening? Okay, fine. So for variance, if you see, the formula is B minus A by 6. So what is B? So I'll write sigma A. Okay, that is sigma. First one for A activity, sigma A is equal to, what is B? B is equal to 8. 8 minus A is 4. 8 minus 4 divided by 6. 8 minus 4 divided by 6, I'll be getting 0.666. Okay, so if you want, you can write it in fraction also. I think you'll get 2 by 3 or something. Okay, 8 minus 4 is 4. 4 by 6 is 2 by 3. So this will be 2 by 3. If you want, you can write it in fraction also, not an issue. 2 by 3, which is equal to 0.666. So similarly, I am calculating for all the other activities. That is B, C, D, E, F, G, H, and I. Okay, so you know variance is sigma I square. Variance is equal to sigma I square. Okay, so we need to square this for variance. So for squaring, directly square. So we are getting for the first activity 0.4435 and so on. I am getting all the other values here. Okay, so variance we have found out, but what all we need to use, we need to only use the critical path, the values of the critical path. Okay, so if you see here, for variance I have taken certain values here. Okay, I have taken certain values here. Okay, so these values how I got, so the critical path, if you see A B E G I, A B E G and I, A B E G I. So I cannot mark it here. I'm getting other okay, A B E G I. So I'll just mark it here as well. A B E G and I. So only these values I need to take. So for A it is 0.4435, for B it is 2.7755, for E it is 7.1075, for G it is 1.7768, and for I it is 0.1108. So this you calculate later, you'll be getting these particular values only. Okay, so if you see here, see 0.4435, 2.7755, 7.1075, those values only I'm taking, and when you add, I'm getting 12.22 as the variance. So this is sigma I square. Sigma I square is equal to, sigma I square. Variance, this is variance. Sigma I square is equal to this, and variance standard deviation is equal to root of 12.22, that is 3.49 days. Okay, root of 12.22 is equal to 3.49 days is my standard deviation, that is sigma. Okay, so this particular sigma, this is the standard deviation 3.49, and we are using this in the calculation of the probability. Okay, so if you see what is the second one, mean time or expected time is 47 days. So what is second one? I'll go to the question. Second one is 55 days. What is the probability of me completing the whole project in 55 days? Okay, so now whatever I have got, this 47 will be my x bar. Okay, and mu is 55 days. So I'll go back, sorry, opposite. I'll just explain you there. So if you see here, mu is 47 days. That is the mean. If you remember the bell curve. Okay, if you remember the bell curve, so this is mu is 47 days. 47 days. So you can take down this, the bell curve. And what is the x bar? So this is x bar. This is x bar is equal to 55 days. So 55 will be after 47. So this is 55. So which area I am interested in? I am interested in before 55. So this whole area, okay, this whole area will be my area to find out, or the area of study is my area wherever I have marked now 47, between the 0 to 55. Okay, so this whole thing is my area of interest. So for 55 days. So now sigma is 3.49 days. X bar I am having mu. So what is the equation, we have z is equal to x bar minus mu. This is x bar minus mu divided by sigma. So x bar is 55 and mu is 45, sigma is 3.47. We just calculated here sigma for 3.49 or 47, whatever. I have written 47, we have got 49 here. So make it correction, I might have done some mistake. Okay, for 49 and 47. So there might not be much of difference. Okay, in points it will be, and I'm getting 2.28. The value is 2.28. Okay, so for 2.28, using the z tables or using the z distribution tables, the value of 2.28 is 0.4890. Okay, the one which you have, okay, you have used for the examination, okay, in the normal distribution. So in that table only, if you see, okay, so that table is of this category, like this is the bell curve. Okay, so it's of something like this. If you see on the top, so it is something like this. So this, like this it is there. So that means whatever value, so 47 to 55, whatever is there, only that value it is giving you. So this particular value only it gives that particular table. But I am interested in the total, so even this I need to add. Okay, so even this I need to add with this particular thing. So this, you know, the center point is always 0.5. Okay, from starting to the center point it is always 0.5. So I need to add 0.5 to this. So 4980 plus 0.5. So if you see here next, 0.5 plus 0.4890, which is equal to 0.9890. That means the maximum probability is there of finishing in 55 days, because my normal duration is only 47. So after 47, any time I could finish. So 55 is way too high. So that means 0.9890. It's almost, if you what you call, uh, if you go on lowering the digits, or what do you call, so encircle this. So if you go on seeing here, so 9 more than 0.5, we need to add 1 to the before one, right? So 0.9, I'll cancel this becomes 9. Okay, so if I cancel this also, this becomes 10. That means maximum probability is there, so almost nearing to 1. Okay, is equal to almost nearing to 1, but don't write it as 1. So write it as 0.9890 only. Okay, so that is what is expected to be written. Okay, so don't do all these things, I'm just explaining. Okay, so 0.9890 only is required. So if you see, the maximum probability of getting the work done or the project completed in 55 days is 0.9890. Rounding off, we are getting around 1. So this is the value of the second one. So second point. Okay, so if you see here, second one, mean time we have taken. So to complete, so it is written the probability of completion within 55 days is 0.9098. Okay, so similarly, if we see here, next one, what is the thing? 500 per day and not more than 2000. So when will I get, like, how many days if I uh, extend it, I'll be paying 2000. So the penalty is 500. So divided by 500. So what is the maximum I can pay? That is 2000. So 2000 divided by 500 will give me 1 za 4 za. So that means maximum 4 days I can extend from 50 days. So here 50 they have given. So my mu will be 50. My mu will be 50. My x bar will be 50 plus 4, that is 54. Okay, so with that particular thing we need to calculate. Only thing, instead of number of days they are giving you the 2000. The maximum payment or the maximum penalty that I'll be giving is, that is 2000. Okay, so what is the probability I need to make, find out, of maximum 2000 paying the extra amount or the penalty. Okay, so to calculate that, what is the penalty divided by total amount? So 2000 divided by 500 will give me 4. Okay, so that is the extra number of days. So 50 plus 4 is 54. So I have not done that. That will be for your homework. Okay, I'll just tell you. So in this case, mu is equal to 50. You can note it down. Mu is equal to 50. X bar is equal to 54. X bar is equal to 54. Okay, sigma will remain the same. That is what, 3.47. 3.47. Just check, 3.47 or 3.49, whatever it is. Okay, that will be the same. Okay, and I'll just draw the uh, curve also for you. So 50 is here. Okay, then 54 is here. So I want this value. Okay, 50 and 54 is there. I want this particular value. No, 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 no. We cannot take like this. So the thing is, sorry, duration we already found out, right? So I cannot remove that. So this is wrong. That 47 is already here. Mu is already 47 only. We cannot take that. Mu is 47 only, not 50. So x bar we need to change. Correct. So mu we are not changing. Even if you remember in the normal distribution also, mu will not change, but x bar we are changing. So mu is 47. So I got confused here. Mu is 47. Okay. So mu is 47 and the first x1 or the okay we'll take it as x1 only. So it is 50 and the other one is 54. 50 to 54. So this value, not the other one which I have calculated here. So this value we need to find out. So how to do that? I'll just remove this off. I'll just remove this. So how to calculate again I'll tell you. So first we need to calculate 47 to 50. So take x bar as 50. So the first one. So first one I'll write it here. So initially first take x bar as 50. Okay. So I'll remove this one as well. Instead of 54, this mu will be 47 always. X bar will be 50. So calculate that first. Okay. So that means I am getting this value. This particular value I'll be getting. Okay. Next, second one. Take mu is equal to 47 again. It will not change. Mu is equal to 47. X bar. X bar is equal to 54. 54 and standard deviation remains the same. Sigma is equal to 3.47. Okay. So again what I am getting? I'll be getting 47 to 54. This value I'll get. So what I need to do? I need to remove the value of 2 minus 1. Okay, always it is 2 because 2 will be bigger. So 2, okay, minus 1 if you do, you'll be getting the value directly. Okay, this value will be getting. So if you see like this, I want this value, this is x. Okay, this is x. I'm having two values, that is 47 to 54 and 47 to 50. So if I subtract, that is 47 to 54 minus 47 to 50, I'll be getting whatever probability I need here. Okay, and the answer for that particular value is I'm getting the probability P of paying less than 2000. Sorry, this is opposite. Okay, less than 2000 is probability. This is P is equal to 0.1721. I'm getting the value as 0.1721. So copy this and you can solve it later. And mu for second one, what I'm getting for second one, it is 2. Okay, for value is 2, z value is 2. After calculating, what I'll get? I'll get point 2, 0.4772. Is equal to 0.4. This is 0.772 is this value, and for 1 I'm getting this is equal to 0.3057. 0.3057. So when you subtract 0.4772 minus 0.3057, we are getting 0.1721, and this is the probability in percentage. If you see multiplied with 100, that is 17% is the probability of me giving less than 2000. Okay, so this is the probability, or you can add 0.5. So this is total we need to find actually, but for us this is more than enough. Okay, or we can add 0.5 to this. So total we need, right, till here to here. So but we required here actually this part, right? So that is 0.1721. So this is the answer for this particular thing. So similarly, only uh, what you call additional to the CPM is this particular probability, where we need to find out the variance and the standard deviation. So if you see variance, we have already find out. So you can write the last value. So here the value for fifth one, variance of the project length, you can directly write this value. So that is 12.22 is the variance. Okay, and the probability for the first one is 0.4890. The second one 0.1721, that is the probability. So this ends this particular problem. Okay, so in the next class we'll start with the new chapter. Okay, we'll start with the new chapter, the last chapter in this particular syllabus. Okay, so this is important CPM for you. So if you want, I'll send some practice problems. Okay, so you can try and solving it. But the base is the drawing the network diagram. You should know the forward pass, backward pass, how to calculate the critical path. Okay, so find out the duration. Then after that, finding out the sigma and sigma square, that is standard deviation and variance. Then using that, using the normal distributions, that is equal to x bar minus mu divided by sigma, we are finding out the values, and using the z distribution tables, corresponding answer based on whatever the question is, whatever the required what do you call the area in the bell curve. So based on that, add or subtract whatever you need to find the result. But only one difference here is in PERT you will be given three values. Okay, three what do you call the durations, okay, for each activity. So for the three durations we need to find out TE using the formula, that is a TE is equal to a plus 4m plus b divided by 6, and the sigma formula, that is standard deviation, is b minus a divided by 6. Okay, so always remember to find the standard deviation directly, don't add these. First find out the variance, add the variance, then take the root of it. Okay, so that's how we need to calculate the standard deviation, and using that do the other stuff like finding the probability. Okay, so this ends today's class. In the next class we'll start with the next module itself. Okay, so we'll stop here for today. We'll continue in the next class. Okay, students, practice this, okay, properly, so that you don't get confused here and there, right? So we'll meet in the next class.